In this video, we're going to talk about minimum distance and triangle inequality. So we'll start with a simple observation. Given 2 points, let's call the first point A, a second point B. What is the shortest distance between A and B? And most of us know just by intuition. The shortest distance is the straight line segment connecting the point A with point B. Okay, forgive me that I'm not drawing that line that straight, but assume this is a straight line from A to B. And this is the shortest distance between A and B. And this is something that we cannot prove. Rather, we just take that as a fact. And in mathematics, it is necessary that we need to take a few things as truth upon which a rigorous mathematical system can be derived. And these truths are called axioms. So here we have this axiom. On a flat surface, the shortest distance between 2 points is a straight line segment connecting them. So for A and B, you connect that straight line. This is the shortest distance, meaning that no matter however you go using a different path, the other path will be longer than this straight line segment. Now this axiom is due to a mathematician named Euclid, who lived about 2,300 years ago. And he built a lot of facts about geometry. In fact, most of geometry you are going to learn up to high school, even in college, will be mostly due to him. And that branch of mathematics is actually known as Euclidean geometry, a name basically after him. So we know that the path that connecting A to B, the shortest one is from the straight line from A to B. What interesting facts we can get from this seemingly extremely simple fact. Now we know that because this is the shortest path, any path I do, let's say I do a path like this, okay? This path will be longer than this straight line. And of course you can just measure it, and it's going to be true. Or you can do something like this. It's going to be longer than the straight line A to B. Now in particular, one of the paths we're going to consider, it will be a path look like this. Assume that we have another point C, and we first go from A to C, straight line, and then from C to B, we go another straight line. Since this is another path going from A to B, by just going from A to C first and C to B, so this is the path, correct? And by the fact that the straight segment is the shortest distance, meaning that this path, AC and then CB, it will be longer than this path, correct? And this will be known as triangle inequality. Let me write down this more clearly. So we have A to B. This is a straight line segment. And we have another point C, from A to C, and then C to B. And to illustrate this point more clearly, I'm going to using a bit of symbol. For A to B, I call this length as Z. For A to C, I call it X. And C to B, I call this length Y. Now the fact that AB is the shortest distance between A and B, no matter which path you go, we know that X plus Y will be bigger than Z. Okay? Correct? By the same token, for B to C, BC, this y is the shortest distance because that's the straight segment connecting B and C. So z plus x is going to be bigger than y. By the same token, z plus y is going to be bigger than x. And these are known as the triangle inequality. And this is one of the most fundamental property of a triangle. As long as these three numbers satisfy all these three inequalities, you can make a triangle. And if you not satisfy one of the inequality, you cannot make a triangle. For example, if I say that in a triangle, the three side lengths is 1, 3, and 5. You can immediately say that's impossible. Why? Because if a triangle goes like this, 1 and 3, and this is 5, I'm plotting like if there's a triangle 1, 3, 5, that means going from A, B, going from A to C, and then C to B is add up only the path is 4, but from going from A to B, the distance is 5. And 1 plus 3 is less than 5. That violates the triangle inequality, but fundamentally it violates the axiom that the shortest distance between A and B is a straight line. You never can have something 5 which is bigger than a path that going from A to C and then C to B. All right. So what this triangle inequality means, it really means the following. 1, given two sides, the third side given two sides, meaning that the length. The third side cannot be too large. Why is that? Because for any number, any z or x or y, the sum of the other two has to be bigger than that number. So the third one, the side, that third side length is going to be less than the sum of the other two sides, right? Cannot be too large. But that also means neither can it be too small. All right, why is that? Why it cannot be too small? That's because that if x is too small, let's say x is too small, then the too small number plus y is going to be not as big as z. Mathematically, I would say just from here, x has to be bigger than z minus y. From here, z has to be bigger than y minus x. Or here, y has to be bigger than x minus z. So all those side length is going to be limited by the difference between the other two sides. So again, let's see. This is actually equivalent to the sum of the two is bigger than the other. For example here, given the two side lengths is 5 and 3, this side is going to be bigger than 5 minus 3 just because that this length as 3 has to be bigger than 5. Okay? So in this lecture, we have learned that the triangle inequality is really just from the fact that this axiom on a flat surface, the shortest distance between 2 points is a straight line segment connecting them. And the triangle inequality is a fundamental property of a triangle. And this is the criteria to check if three numbers, given three numbers x, y, z, can those three numbers make a triangle or not? And to check that, you only need to check these three inequalities. In fact, you really only need to check one inequality. Why is that? You just find the largest number among the three. Let's say the three numbers are 10, 11, and 15. You just find the largest one and just check the other two numbers, the sum is bigger than that number or not. And give it a thought why that's the case. It should be straightforward. Okay, this is the triangle inequality. And the equivalent way of saying it is actually the following. If I denote P, the perimeter of the triangle, as P, so P equals X plus Y plus Z, right? The definition of perimeter. Then we know that on any of the side, the length is going to be less than half of the P. Y is going to be less than half of the P, and Z is going to be less than half of the P. Okay, also give it some thoughts why that is the case. And that's the end of this introduction of triangle inequality. In the next video, we're going to look at application of this inequality into real life problems.